Hello teachers, welcome to section 7-4. We're going to talk about percents today. Fractions, decimals, and percents as representations of rational numbers with conversions from one form to another, proportional relationships to solve percent problems, techniques to solve problems including discounts, interest, compound interest, and percent increase and percent decrease, and strategies for percent mental computation and estimation. So percents. Percents are special kinds of fractions, namely fractions with a denominator of 100. The word percent actually comes from the Latin phrase percentum, which means per 100. It was first originally created probably to handle taxes. Definition of percent. N percent is equal to n out of 100, where n is any non-negative number. So for instance, if you have 80%, that's equivalent to 80 out of 100. They mean exactly the same thing. So here's our first example. Write each of the following as a percent. You probably are very comfortable with this. To change a decimal to percent, you know the drill. You move the decimal 2 places to the right. But why is that? So if I move that 2 places to the right, that answer is 3%. But why is that true? Well, if I read this decimal, 0.03, remember I'm failing myself and I'm failing you, that's really the decimal 300ths, right? So that is 3 out of 100. And remember, a percent means the amount out of 100. So this is 3 over 100, therefore that is 3%. So that's the way I want you to think about it. I'm perfectly fine with you moving the decimal 2 places to the right to say you have a percent, but really what you need to be thinking about is what part of this out of 100 do you have? So I've got this typed up. There's your 3% right there. What about B over to the right? Notice that is a 3 repeating. So if I use the idea that this is 0.33333 repeating forever, correct? And I move the decimal 2 places to the right, this gives me 33.3 still repeating percent. Now we already know that that's equivalent to 33, the 3 repeating is 3/9, which is actually 1/3%. Okay, both of these are correct. Right, you have to have the line over that 3 though, so either one of these is correct. If I show you the typed up version, notice they have 33 and 3 repeating percent. What about 1 2/10? Well, if I move the decimal 2 places to the right, then here I don't have a sign there, so that would be 120. Don't forget to add the percent sign. But what if you think about this in terms of fractions? That's 1 2/10, okay? Or you could say that's 12/10, but it's not out of 100. So how do we fix that? Well, you just multiply the numerator and denominator times 10 over 10. 12 times 10 is 120 over 100, and then you can clearly see that is, excuse me, 120%. So again, think about it in terms of fractions. That's really what's happening, and moving the decimal over 2 places to the right is just a cute trick to get us there. And there's that 120% for us. What about the next one? As a matter of fact, how about you pause the video and go ahead and finish these out, and that way you know if you're going to struggle with any of them before I get to it. All right, how did it go? So if I move this decimal 2 places to the right, I have 0.042, which is really 42 thousandths, and don't forget to add that percent sign. So that's a little bit more challenging to figure out how to get that out of 100, but you could certainly do it. What about 1? That's just 100%, right? By the way, let's look at the typed up version. There it is. 1 is 100%. Move that decimal 2 places to the right. 3/5. What could we do about that? Well, 2 ways you can handle it. You could do 3 divided by 2 in your calculator. Okay, so if I did 3 divided by 2, I mean 5, not 2, I apologize. 3 divided by 2 in my calculator is going to give me 0.6. I move my decimal 2 places to the right, that would be 60%. How do you think about that in terms of fractions? Well, again, let's go back to the 3/5. I need 100 on the bottom. Can I just put 100 on the bottom? Well, sure. I can multiply the denominator by 20 and the numerator by 20, and that will give me 60 in the numerator and 100 in the denominator. And there's your 60% that way as well. So I encourage you to think about these both ways. Okay? All right. 2/3. What are we going to do there? Yeah, let's look at the typed version. There's that 60% that you needed. We needed that space. So 2/3, what did you do? Well, if you typed it in your calculator, then you got 0 and the 6 repeating. So if I move 2 places to the left, I need to look at that in terms of this situation. Take that on out. 2 places to the right, I apologize. That would be what we have there. So that would give us 66 and then 6 repeating percent. Another way to write that is 66 and 2/3%. Both of those would be correct. So you'd have to look at what best suits your result. Okay, either how the homework asks you to put it or whatever you're working on. Okay, now 2 1/7. I can't easily change 7 to 100 in the denominator, so I highly advise just plugging that in your calculator. Now, that is going to be a repeating decimal, right? Because anytime your denominator cannot be written with prime factors of only 2 and or 5, then you're going to have a repeating decimal, just like the 3 in this denominator, but the 5 had a terminating decimal. So this is a repeating decimal or a non-terminating decimal. If you plug that in your calculator, what are you going to get? And you probably recognize that fraction from a problem in a previous section, but this would be the 2 for the whole number part, and 0.142857, and then it starts over again. So there is the repetend, right? And if we write that in percent form, I move 2 places to the right, so that's 214, and then again repeating, it'd be 2857 and then 142857. So that bit would be repeating. Now let's see how the book decided to answer that question. So there's your 66 and 6%. Look at that. What in the world did they do? That's not what we put for our answer, right? What could we do? Let's see if we can do this 2 1/7 without changing this to a decimal. I have kind of an unconventional way, but I'm going to change this to an improper fraction. So you got 2 times 7 is 14 plus 1 is 15 sevenths. Now we need this out of 100, right? Okay, so I'm going to multiply by 100 over 100, which gives us 1,500 over 700. But now I really still just need that out of 100. So you know what I'm going to do? I'm going to take that 1,500 or 1,500 and divide that by 7. Why am I using long division? Because I want to write it as a fraction. So we know that 7 divides into 15. 2 times 7 is 14. That leaves 10, right? 7 goes into 10 one time. 1 times 7 is 7. Subtract that leaves 30. 7 divides into 30, but 4 times, 7 times 4 is 28. Bear with me. If you were doing this on paper, you could do it. And then the remainder is 2. Notice what's going on. That's 214 and 2/7 out of 100. Because remember, I ignored the 100. I just divided by 7, which also gives us 214 and 2/7%. There are many other ways you could handle that. I think that was the easiest, other than jumping to decimal in your calculator, but notice they did not give a decimal result here. Let's try a few more. All right, write each of the following percents as a decimal. Now notice we're going the other way. So if we scooted our decimal 2 to the right and removed and added the percent is what we did, right? If we go back and look at our results, we scooted the decimal 2 places to the right, and then you added the percent sign. Well, if we go the other way, if we have a percent and we're trying to write that as a decimal, we're going to scoot 2 places to the left and then remove the percent sign. So if you go away from the percent sign, you want to remove it. Okay? Struggling to get my pen to work. Here we go. So where is the decimal? Well, it's right here. If I move 2 places to the left, it's going to be 0.05, and I remove the percent sign. Now, another way to think about that, in terms of fractions, which I really prefer, the percent just means out of 100. So if we have 5 out of 100, that's exactly what this is, 5 hundredths. Okay, so let's try it again. This is saying we have 6 3/10 out of 100. If we just use the definition of percent, right? Now, I'm not allowed to have a decimal within a rational number. That's not proper notation. So I want to remove this decimal. The trick there is to multiply by 10 over 10, and that would give me 63 over 1,000. That changed it to a fraction. Now, 63 thousandths, you could also write as 0.063. Now, is that not the same as just scooting that 2 places to the left? Well, absolutely. Okay. Now, 100% written as a fraction would be 100 out of 100, and we know that's just 1. If I just move the decimal 2 places to the left, that also gives us 1. What about 250%? That's 250 out of 100. That reduces to 2.5, right? Or 2 5/10. Move the decimal over, 1, 2. There we go. That's another way to handle it, okay? What about 2/3 of a percent? That's a little bit more complicated. You could write that as a decimal. So if I divided 2 divided by 3 in my calculator, that'd be 0.6 repeating. Now I move the decimal 2 places to the left. That's going to be 0.006 repeating. And again, you're losing the percent sign when we do this, so you don't add that percent sign in. And then 33 1/3, again in decimal form. This is what we're dealing with, right? That's percent as it is. If I move that 2 places to the left, that's 0.33 repeating, no percent sign. Is that not just the number 1/3? Well, it is, right? Now, let's see what their answers look like. So there's the 0.05 we talked about, the 0.063. Notice 2 places to the left. 100% is just 1. 250% is 2.5. How did they handle this one? So the 2/3% is, notice 0.006 repeating. They did decide to write it that way. Your little bar doesn't have to be red like that one. And then you've got the 0.3, again, repeating decimal percent. That's the way we handled both of those. Okay? What about application problems involving percent? Well, applications involving percent usually fall into one of the following forms. Finding the percent of a number, finding what percent one number is of another number, and finding a number when a percent of that number is known. Now, there are a couple of different ways to handle these, and I want to show you both ways because you want to know every way around it, and there's even others. I love the equation form, but if you're not dealing with algebra yet, you might not be able to teach this in terms of an equation form. So, again, 2 ways to handle it. Some teachers teach is over of equals percent over 100. Another way to say the very same thing is part over total equals percent over 100. Okay, this one makes a lot of sense. So you're talking about the part over the total amount equals percent over 100. This one is based on the language. So whatever your percent goes right here, out of 100, you know why that's there, because that's what a percent is. It's some number out of 100. Is the is number. When you read it, you'll see what we're talking about. And of is the of number. So you'll see, but it really is corresponds to the part, and of corresponds to the total. So a house that sells for $92,000 requires a 20% down payment. Now what we're really thinking here is 20% of $92,000. Okay. Now, these can also be done very quickly, something like this. You know, in math, most of the time when you see of, that means multiply, and it does apply here. So we're going to evaluate 20% of, which means multiply, 92,000. That 20% you could change to a fraction as 20 over 100 times 92,000. It would be real easy just to cancel your zeros. And then you multiply 920 times 20. And that results in 18,400. Okay, another option is change this 20% to a decimal. So I'll do that in purple. How about 0.20, which is 20%, times 92,000. Of course, that's going to give us the same amount, 18,400. Now, does that seem reasonable? Always ask yourself, is your answer reasonable? So a 20% down payment, would $18,400 seem like a 20% of 92,000? Yes, that seems completely reasonable to me. So it makes good sense for an answer. Notice I didn't use either of those formulas, but you could think about it in terms of part over total equals percent over 100. Let's try that in green. Okay, so you have your part, that's what we don't know, okay, over your total, which is 92,000. Our percent is 20 over 100. And remember, to solve proportions, you cross multiply. So here we go. So I don't know what this is, so I could say that's 100 times question mark equals 20 times 92,000. Which I get the big number 184 with 4 zeros. And I divide by 100, that means our part number is going to be 184, and I just need to knock off 2 of those zeros, and then there you go. There's the 18,400 as well. So that's actually 3 different ways to look at this same problem. Now, let's see how the book decided to do it. So it says we need to find 20% of 92,000. That's the first way we introduced it. 20% of 92,000 is the 0.20 times 92,000, which is the 18,400. So we know the down payment is 18,400. Now let's try another problem. So we have Alberto has 45 correct answers on an 80 question test. What percent of his answers are correct? This one to me fits great the model of part over total equals percent over 100. Okay, so Alberto has 45 correct answers. That's part of the total test, which has 80 questions. And we want to know the percent. Again, you could call it question mark, you could call it anything you want, over 100. Now here's what I want to caution you about using this formula, either this one or the is over of. Your answer is in, it's already a percent. Okay, so you've got to remember to add the percent sign. So when I cross this way, that's 4,500. I cross this way, that's 80 times question mark. I need to get the question mark by itself, so I am going to divide both sides by 80. Notice this concept still involves algebraic ideas. You have to know how to get this question mark by itself. So 4,500 divided by 80. That's going to give me 56.25. Remember to add the percent sign. Now there's another way to think about it too. Of course there is, right? just part out of total, if I just divide 45 by 80 right off the bat, that's going to give me the decimal 0.5625. Okay, so that is just a rational number or a fraction. Now to convert that to a percent, you just move the decimal over 2 places to the right, and there's your 56.25%. So if you just have a part over total, you change it to a decimal by dividing, and then you convert that to a percent out of 100. Now see what they did. They used the part over total model. Okay. Ooh, sorry about the slide there. My pen quit working again. So right here, so 45 over 80, the part over total, equals n. That's your missing value. We called it a question mark out of 100. Let's keep going with our examples. Okay, so 42% of the parents of the school children in the Paxton School District are employed at Diploma University. If the number of parents employed by the university is 168, how many parents are in the school district? Okay, now we could think about this in terms of part over total equals percent over 100. All right, so let's see if we can figure this out. So if the number of parents employed by the university is 168, how many parents are in the school district? So what are we missing? Well, to me, it sounds like we're missing the total parents in the school district, right? We have the part, we don't have the total. So let's see if we can set up our fraction. So 168 is the part. We're going to use n for the total like they used in the previous problem. The percent, notice it says 42%, so that's going to go in the percent spot. And then out of 100. And then once again, proportion, I can cross multiply. So 42n equals, and then 168 times 100. Over here on the right, I've got 16,800. On the left, I still have 42n. You know what I'm going to do? I'm going to divide by 42 on both sides so I can get that n by itself and just type that in my calculator. So I've got 16,800 divided by 42. If you didn't have a calculator, we could certainly use long division and easily come up with 400. Now, what are we looking for? How many parents are in the school district? So this is 400 parents. Always consider your units when you're doing application problems. Now, you'll notice here, this is kind of inconsistent with the way they've been doing problems, but this uses more of the equation model, okay? So 42% of n. So remember, we could say put 42 of means multiply. N is always equals right here, 168. And then you can divide by the 0.42, and you're still going to get that 400 that we came up with. So again, different models to do these. I think it's great to understand all of the different versions of this. Another problem, skis at a sports store near Humphreys Summit are on sale for $476. If the original price was $560, what percent were they discounted? This is a discount problem. Now, again, I really love part over total equals percent over 100. Well, that get us there. So it says they're on sale for $476 of the original price. What percent were they discounted? So we could calculate what percent was remaining. There's a couple ways to handle this. So I'll show you my version of this, and you can look at their version of this. So the part is definitely $476. The total was $560. We want to know what percent that is. Now, keep in mind, this is how much percent you would pay, not the discount. So when we calculate this, we cross multiply. So cross this way, you have 47,600. Cross the other way, that's 560 times x. I'm going to divide by 560 on both sides to get what that percent value is. So 47,600 divided by 560 gives me 85. So my x is 85. Remember, you add the percent sign if you use this formula. Now, was that how much it was discounted? No, that's how much you pay is 85%. So that means the discount must be the remaining out of 100. How about 15%? Because we could do 100 minus the 85 that we pay, and it means the discount is 15%. Now, likely, the textbook is going to do this a little different. Let's just check out what they did. It says that the original price was $560 and the new price is $476. The skis are discounted $84. That works very well. They calculated how much the discount was, and then they did the work that we did. The discount would have been taken from the original price, so we need to find what percent of 84 is 560. And then they worked their way through the problem as well. Okay, and of course you see they got 15% also. So we could have calculated the discount first and then used part over total equals percent over 100. And then our percent would be right there in front of us. Mental math with percents. A good thing to know is percent and the fraction equivalent. So anytime you hear 25%, that's just 1/4, right? Because that's 25 out of 100. That's what percent means, which reduces to 1/4. 50% is 1/2. 75% is 3/4. Again, why? Because that's 75 out of 100, and that reduces to 3/4. 33 1/3% is 1/3. That's a good one to know, because often you think 33% is 1/3, but it's really 33 1/3, because 1/3, remember, is a repeating decimal. Same thing with 66 2/3%. That is the number 2/3. 10% is 1/10. 1% is 1/100. It's really good to know these yourself and talk to your students about that. So use a known percent. Frequently, you may not know a percent of something, but we know a close percent of it. For example, to find 55% of 62, this is some interesting advice that you might could use if you were in the store. 50% of 62 is half of 62, which is 31. And then 5% of 62, that's the other, if you're looking for 55%, is 1/2 of the 10% of 62. Now 10% of 62, you just move the decimal over, is 6.2, and then half of 6.2 is 3.1. You add those together to get 34.1. I use percent mental math calculations when I calculate a tip frequently, because it's easy to calculate 10% of something and then double that amount to get 20% for a tip. So just little tricks. Estimations with percents can be used to determine whether answers are reasonable. That's always a good value of doing estimations. Here's an example. Laura wants to buy a blouse originally priced at $26.50, but now on sale for 40% off. She has $17 in her wallet and wonders if she has enough cash. How can she mentally find out? And just say ignore the sales tax, because that's an entirely different calculation, right? So it's easier to find 40% of $25 versus $26.50, right? So 40% of $25. So how could you do that? Well, 40% of 25 would be 4 times 10%. Remember the tip trick I just told you about to calculate 20%? Just do 10% twice. Well, to do 40%, you do 10% 4 times. So 10% of $25 would be $2.50 times 4, right, would be $10. So it's going to be $10 off, but keep going. Laura estimates that the blouse will cost $26.50 minus $10, $16.50. Since the actual discount is bigger than that, Laura will have to pay less than $16.50 for the blouse, so she has enough cash. Again, this is without tax. So mental math tricks can be very helpful when working with percents. Now, let's talk about these, and then we'll shut the video down and then come back for part 2. There's a part 2 for this. Which of the following statements could be true or which are false? Okay, so let's just look at this one at a time. It says Leonardo got a 10% raise at the end of his first year on the job and a 10% raise after another year. His total raise was 20% of his original salary. Is that true or false? And if it's false, you've got to be able to argue why it's false with a counterexample. So keep that in mind. Now, I argue that it's definitely false. And you could just try it with, you know, $100 or a $100,000 salary, whatever you want to use. The smaller numbers make it very, very clear and less work. But a 10% raise, and then the second 10% raise is going to be all over more money than the original 10% raise, right? So that's like compounding the raise. So that will not be 20%. His raise will actually be more than 20% of the original amount. So that is definitely a false statement. Okay? Why don't you pause it and think about the next one. So Jung and Dinah paid 45% of their first department store bill of $620 at 48% of the second department store bill of $380. They paid 45% plus 48% is 93% of the total bill. What do you think? Does that seem reasonable? That you just add percents together like that? I would say no, that this one is also false. Why in the world would that be false? Well, 45% of 620, yeah. And then 48% of 380, you're talking about different amounts. Now, if these were both based on the same amount, if it was 45% of 1,000 and 48% of 1,000, then you could add those together to get 93% of 1,000. But since these amounts are different, then it's different. Now, I think it's worth the time to calculate this. Actually take 45% of 620, which we just multiply, 0.45 times 620, then take 48% of 380, okay? And then calculate 93% of the total and see if that worked. It won't. Just two more of these true-false situations, and then we will stop the video and come back for part 2. So Bill spent 25% of his salary on food and 45% on housing. Bill spent 25% plus 40% equals 65% of his salary on food and housing. Now, compared to the last problem, it seems like this would be false, right? But remember, we're taking the 25% and the 40% on the same thing. That's of his salary. Both of them are on the same calculation. So it is true that he would spend 65% of his salary, because 25% of his salary plus 40% of his salary would equal to 65% of his salary. So that is true. But if your percents are of different amounts, you cannot add those percents together. And what do we think about this one? In a town, 65% of the adult population works in town. 25% works across the border. And 15% is unemployed. It says everyone in town is exactly one of these categories. So it's telling you that it's speaking for everybody. And what do you think? Is this even possible? You know, what's 65? No. What's 65 plus 25 plus 15? If we add all those percents together, you get 105%. How can that be? So this is definitely a false statement. That is not possible. When you're talking about percentages of things, you can't have more than 100% if you're accounting for everybody. Now, that's not to say more than 100% doesn't exist. It depends on what you're talking about. But in this situation, that's impossible. Okay, and so you'll see that that is a false statement. So we'll come back for part 2 of this video, where we do more application problems with percent. We also talk about interest problems, and I do some homework examples. So have a good day. Talk to you soon.